Okay, then let's do some more. Okay, okay. Here, OLS function here. Then now I would try to plot the residuals and then fitted value against the dependent variables. Okay, here. Let's try the residuals first. Whenever you try to plot a figure, then you have to declare figure, then plot. Then where is the residuals? E hat. E hat is the residual. Okay. Then it's done. Okay. Then save it. And then here, just run it. Then this figure will pop up. Then you can see this is the residual. Residuals must fluctuate around 0. Right? Then it would be better to add 0 line here. Right? 0 line. Okay, let's do this together. Here, then bracket, then zeros, capital T, comma 1, and bracket. Okay, so then now let me run this main file again. Yes, here. Okay. Then also I would try to plot the dependent variable and fitted value. Okay, dependent variable is y. Okay, and what is the fitted value? Fitted by the mother. Fitted by independent variables. Where is it? This one. X times beta hat. Right? Let me go back to the DGP, data general process. So this is how y is generated, right? Then you see that y can be decomposed into two parts. One is something explained by x and something unexplained by x. So, right? So this part is implied by the mother. So, right? This part is implied by mother, and this is something unexplained by the mother. So, right? So then, but we have no true values for beta. So that's why we have to use the estimate of beta. So which is beta hat. So x times beta hat. Here, x times beta hat is the fitted by it. This is the fitted value, right? So then here, let me define y. Let's say y hat equals x times beta hat. Okay. Fitted value. So then y hat, right? So then if y and y hat fluctuate very closely, so then x has very strong explanatory power, right? Or we can say that x are very good regressors or good independent variables, right? Otherwise, if y and y hat or I would say y hat doesn't follow y very well, then we chose a wrong regressors. So actually x is not very highly related to y. So right. So then to see this, we have to plot y and y hat both together. Okay. That's why we are doing this. Okay. Okay. Then let me run it again. Now we have two figures, right? So then this one must be residuals. But what about this? Can you tell which one is y and y hat? No. It would be better to add legend here. Okay, let's do this together. Legend. The first one is what? The first one is what? The first one is the actual value. That's why I say y, or dependent variable. Dependent. The second one is fitted value. Right. So then let me run it again. Yeah, so blue line is dependent variable and red line is the fitted value, right? Fitted value. Okay, so now you see that every time you run this code, we have two figures, but I wish these two figures are shown in one window. That would be looking better. So then, in that case, I would say subplot. Say 2, 1, and no figure. Now subplot 2, 1, 2. Then yes, it's done. And then I will explain after running this. Okay. Let me run this. Okay. Now you see that in one window we have two figures. So right? We have two figures. So right? So then now you may wanna add subtitles. I mean here, subtitle here, and you wanna see what this is one and what this is, right? So then here let's add title residuals. And make a copy here. We'll say y and y hat, right? Y hat. So then now we have subtitles, right? Let's see what happens now. Yes. Oh, this is subscript. No, this is not what we want. So then I would say so then so then just fitted it. And dependent and fitted, right? Let me run this. Right. Okay. So then you see that this red line is fitted value and blue line is the dependent variable. And you see that red line doesn't follow the blue line very well, right? That's why here r square is very low. It's very close to 0, right? Why? Because you see that there are two independent variables, and relatively the sigma square is large. Sigma square measures what? it measures the size of errors, size of these errors. This is relatively bigger than this x prime x times beta, and particularly here, the second beta is 0, right? So it has only what? The first independent variables, which is just constant, right? Instead, if the true value for x beta 2 is, I would say 5, right? 5. Then the second regressor x2 is important, right? Because it has a large impact on y, because the beta is 5, beta 2 is 5. So then let me run it. Then you see that here is the red line and blue lines are very close, right? Now R square is very large, right? Okay. Of course, beta estimates are close to true values, of course. All right. So then, and then let's try just last thing, just one more thing. Then again, whenever you run this, always this figure pops up and you see this table, but sometimes you don't want to see this, and then I would like to add, it's called flag. Okay, let's go to the function. I will say let's say print I. Oh no, is it print? Yeah, it looks better. It's print, right? So then here, if is print equals 1, if print equals 1, you see this, there are equal marks, there are two equal marks here, and again. Okay, so this is if statement. Okay, and then just select all, control R, okay, control, and then press the right button of your mouse. Then can you find smart indent? Yes, press this one, smart indent. Then you see it looks better, right? Because now by doing this, you can see where the if statement starts and it ends here, right? Okay, and then let me explain this here. So once you put two equal marks, it means this is statement. Okay, statement. If statement is true, if this statement is true, then the MATLAB will proceed these commands. It means what? It means if is print equals 1, and which is true, then MATLAB will report this table and figure. Okay. So then where is print? Is print is here. So now we have three inputs. Then now that means also we have to define three inputs: y, x, and 1. Okay, so then you will see, yeah, figure. But you don't want to see the tables and figures. Then what? It could be 0 or 2, whatever it. As long as it's not equal to 1, yes, this function will not report the table and figure. Okay, let's try. Okay, nothing happens, right? Let me run this again. Yeah, nothing. Okay, nothing, right? Nothing, right? Okay. So then, I'm sorry. Last thing, I promise. The last thing, okay, the last thing. And sometimes you are very lazy to define 0, 1, okay? Just, you may want to just y and x, okay? Y and x. And if here, if n arg in is less than 3, and then is print, say, 1. Okay, so n indicates number of, this number of, n indicates number. Arg means arguments, which means just inputs. I mean, just variable, and in means inputs. So arg in means the inputs, and n means the number of the number. So then n arg in indicates the number of inputs. If the number of inputs, so if the number of inputs is less than 3, then isPrint equals 1. So this is default. This is default value for isPrint. Of course, it could be 0. Yeah, this story is your core. Okay, isPrint. Okay, all right. So then let's go back to the main file. Here, I didn't specify the third input, right? And let me run it. Yes, you could see table and figure, right? Because we didn't specify the third one. So then the inputs are, the number of inputs are 2. So then isPrint equals 1. Okay, but if we don't have this flag, so then let me insert the percentage here. So these three lines do not exist, right? And let me run it. Here's an error. You can see that not enough input arguments, right? Because this function has 3 inputs, but now here we specified only 2. That's why this metric complains. So then, but if we have this, delete the percentage, then if we run this, yes, and then if you wanna put 0 here, yes, no problem. 0. So then default is 0. So then let me run it. Nothing happens, right? Okay, but if you try to see, if you have to see the table and figure, then here 1. Then let me run it. Yes, right. Yes, right. It's so exciting. Yeah, I love coding. Yeah, I wish you do.